Hi everyone, welcome to another video by Maths with Sarah. So today we're going to be tackling this ratio question. I quite like this question. It's kind of looked at ratio in a slightly different way from the ways that you would normally see it. So quite often it's seen in like recipes, for example, or just general ratio questions, whereas this one's kind of looking at it in a slightly different way. It does come from the very end of the paper 3 from Edexcel, so it's not an easy question. But definitely the first part I think most people could attempt. So as with all these questions, I encourage you to pause the video about now, have a little go yourself, see how far you get. I've just said it's a hard question, but even so, I reckon everyone can have a go at it. So have a little go, see how you get on. If you need any help, then just check back into the video and I'll go through it in a second. So if we're looking at this, we want to find the ratio of C to D. So we've got an equation here, 5c plus d equals c plus 4d. So what we want to do essentially is to separate these out. So we've got the c's on one side of the equal sign and the d's on the other side. And that will allow us to find the ratio. So if we start manipulating this equation, we've got 5c plus d equals c plus 4d. And then we can subtract c from both sides. So if we do that, we end up with 4c plus d equals just 4d. And then if we subtract d from both sides, we end up with 4c equals 3d. So what this means is that every time you've got 4 lots of C, you've got 3 lots of D. So for example, if we substitute in C equals 1, what we would end up with is 4 equals 3D. And if we substitute in D equals 1, then we'd end up with 3 to 4. So therefore, we know that the ratio for this is 4 to 3. Okay, so the next one of these is very, very similar. The difference being that it involves a quadratic, which obviously just makes things a little bit harder. So for this next part, the principles are exactly the same. We're still just trying to collect all the x's to one side and all the y's to another, or to just generally deal with the x's and the y's together. But we've actually got 6x squared equals 7xy plus 20y squared. So we've got squares, we've got x's, we've got y's. It's a little bit more complicated. So where I would start with this one is by moving everything onto the same side. So if we do that, we've got 6x squared, and then we can subtract 7xy. And then we can subtract 20y squared, and that is equal to 0. So now, although it's not exactly the same as the quadratic that you would normally see, it is fairly similar. So what we can do now is we can put this into 2 brackets. Again, set it equal to 0. And then hopefully one of these brackets will give us the answer. We've got this important part of the equation here, that's a part of the question here, which says that x and y are both greater than 0. So that should help us out towards the end of this question. So the way that I normally do these is I will do your A and your C. So let's pretend it's just a quadratic. Let's ignore the y's for now. We'll just use the x's. So if you multiply those two together, and then we look at the factors of those. So if we times that together, we get 120. And then we'll look for factors of 120 that add to make -7. So for factors, we have got 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, and then I'm going to just jump up straight to 10 and 12. I know I've missed a few in the middle here, or definitely missed 8, I think. So the 8 and 15 on that. Actually, yeah, that's an important one. Let's include 8 and 15. And as you can see that these two have a difference of 7. So if we use minus 15 and plus 8, those two multiply to make minus 120, and they add to make minus 7. So now we need to deal with this 6x squared. If we can either use 6 and 1, but neither of these are factors of 6, multiples of 6, sorry. So instead, if I suggest that we use 2x and 3x. So both of these, when they're multiplied together, will give you 6x squared. So now if we do minus 15 divided by 3, we get minus 5. And then if we do 8 divided by 2, we get plus 4. So at this point, I think you're probably sick of me banging on about this, but I really think it's important to stop and check. I just realized I've got to put the y's here, because obviously we have actually got, these are in fact y's rather than just nothing like we would normally have when we're doing quadratics. So I think it's really important that we just take a second here to check that if we multiply or expand these brackets, we actually end up with the answer that we're expecting. So if we do 2x times 3x, we get 6x squared. Then if we do 2x times 4y, that gives us 8xy. Then if we do minus 5y times 3x, we get minus 15xy. And then lastly, if we do minus 5y times plus 4y, we're going to end up with minus 20y squared. So if we combine these two together, you'll see that this will end up as minus 7xy. So luckily, we have got the answer that we were expecting. So we can be fairly sure that at this point, we've at least got something right. So the next step for this is to say, well, which one of these is going to give us an answer where both x and y are positive? So we can set each bracket equal to 0 separately, as we would normally do for a quadratic. So we've got 2x minus 5y equals 0, and 3x plus 4y equals 0. So that's the equal sign. So now if we kind of try and solve these a little bit, what we're going to end up with is 2x equals 5y. So if we just subtract plus 5y to each side, we're going to end up with 2x equals 5y. Or on this side, we're going to end up with 3x equals minus 4y. Okay. So obviously in this one, we've got a negative number, so we know that that can't be correct because we need them both to be positive. Whereas on this side, we've got both of them got positive values, so we know that that's what the ratio is going to be. So the ratio of x to y is 2 to 5. Because we've got 2x equals 5y. So that's the answer to that question. Using ratio in a slightly different way, not a way that you probably will have thought about using it before, but altogether quite a good question, I think. And there's nothing really that is particularly challenging. If you're quite happy with algebra, quite happy with quadratics and solving equations, there's no reason why you can't tackle this question. But just don't be put off by the fact that it's worded in a slightly different way. Okay, so the next video that I'm going to do is looking at some statistics and some histograms. So I encourage you to subscribe to my channel if you're interested in finding out more and having a look at the next few videos. Thank you very much for watching, and hopefully see you when I do the next video.